The United States is a land of diverse landscapes and climates. From the sun-kissed beaches of California to the snow-capped peaks of the Rockies, America's beauty is undeniable. But this vast and varied terrain also makes it a prime target for extreme weather events. Hurricanes, tornadoes, blizzards, droughts, and wildfires. America seems to experience it all, and with a frequency that often makes headlines around the world. Join me as we embark on a journey through America's turbulent skies and volatile landscapes, to understand the forces that shape our weather and how we can better prepare for the challenges that lie ahead. To comprehend America's extreme weather, we must first appreciate the vastness and diversity of its geography. Stretching over 3,000 miles from the Atlantic to the Pacific Ocean, the U.S. encompasses a remarkable range of climates. The warm, moist air from the Gulf of Mexico fuels powerful hurricanes that batter the southeastern coast. Meanwhile, the cold air masses descending from the Arctic plunge southward, colliding with warmer air and creating blizzards that paralyze the Midwest and Northeast. The towering Rocky Mountains act as a barrier, forcing air upwards, causing it to cool and condense, leading to heavy snowfall in the west and creating a rain shadow effect that leaves the eastern plains relatively dry. Understanding these underlying geographical and climatic factors is essential to grasp why certain regions are more susceptible to specific types of extreme weather. America's history is punctuated by a series of devastating extreme weather events that serve as stark reminders of nature's untamed power. Tornadoes, those violent rotating columns of air, are synonymous with the American Midwest, particularly the region known as Tornado Alley. The western states are increasingly plagued by wildfires, fueled by prolonged droughts and tinder-dry vegetation. These events, etched in the annals of America's history, are not mere anomalies, but rather stark illustrations of the nation's vulnerability to extreme weather. Examining these historical patterns and their increasing frequency provides valuable insight into understanding the potential risks and preparing for the future. The ramifications of America's extreme weather extend far beyond the immediate impact of the event itself. Hurricanes and floods displace millions, destroy homes and businesses, and cripple transportation systems. The agricultural industry faces severe losses from droughts, floods, and extreme temperatures, impacting food supply and prices. Roads, bridges, power grids, and communication networks are vulnerable to damage, leading to widespread disruptions and hindering emergency response efforts. Lives lost, homes destroyed, and the psychological impact of experiencing such traumatic events leave lasting scars on individuals and communities. Investing in early warning systems, strengthening infrastructure, and promoting sustainable land management practices are crucial steps to lessen the impact of these extreme weather events. North America, the landmass upon which the United States sits, is a continent of dramatic contrasts, a vast canvas upon which nature paints with an array of extremes. The Rocky Mountains, stretching over 3,000 miles from Canada to Mexico, stand as a formidable barrier, a continental divide that cleaves the nation in two, both geographically and meteorologically. To the west, a world of Pacific moisture collides with these towering peaks, creating a realm of lush forests and temperate rainforests. But to the east, a different story unfolds. Here, the land stretches out in a vast expanse of plains, a sea of grasslands and prairies that roll eastward towards the Mississippi River. This clash of titans, this meeting of extremes, is what fuels the engine of America's wild weather, giving birth to the tornadoes, blizzards, and thunderstorms that define the heartland's meteorological character. Imagine the atmosphere above North America as a vast, three-dimensional highway, with air masses from different corners of the globe constantly on the move. Warm, moist air flows northward from the Gulf of Mexico, while cold, dry air sweeps southward from the Arctic. When these contrasting air masses collide, they engage in a delicate and often violent dance, a meteorological tango that gives rise to the dramatic weather patterns we see across the United States. Cold fronts, like invisible walls of dense, chilly air, bulldoze their way southward, forcing the warmer, lighter air ahead of them to rise rapidly. This rapid ascent of warm, moist air leads to condensation, cloud formation, and often the development of thunderstorms. While the clash of continental air masses dominates the weather of the central and eastern United States, the southeastern coast faces a different kind of threat: the fury of tropical cyclones. These storms, known as hurricanes in the Atlantic and eastern Pacific, are fueled by the heat energy released when water vapor condenses. The warm, moist air over tropical oceans rises like smoke from a chimney, creating an area of low pressure below. This low pressure draws in more air, which in turn heats up and rises, perpetuating the cycle. Hurricanes are nature's heat engines, drawing energy from the warm ocean and converting it into powerful winds, torrential rainfall, and storm surges that can inundate coastal areas. The southeastern United States, with its long coastline and proximity to warm Atlantic waters, is particularly vulnerable to these powerful storms. High above the Earth's surface, in the upper reaches of the troposphere, powerful rivers of wind known as jet streams snake their way around the globe. These fast-flowing air currents, driven by temperature differences between the equator and the poles, play a crucial role in steering weather systems and influencing temperature patterns across the planet. The polar jet stream, the most influential jet stream for North American weather, typically flows in a wavy pattern from west to east across the continent. These waves, known as Rossby waves, can dip southward, bringing frigid Arctic air with them, or bulge northward, allowing warm air to surge farther north. Climate change is also believed to be influencing the behavior of the jet stream, causing it to become more erratic and contributing to more extreme weather events. Mountain ranges, those majestic giants that rise from the Earth's crust, are not merely passive observers in the drama of weather. As air masses encounter a mountain range, they are forced to rise, a process known as orographic lifting. The Rocky Mountains in particular play a pivotal role in shaping weather patterns across North America. As moist air masses from the Pacific Ocean flow eastward, they encounter the Rockies and are forced to rise. By the time the air descends on the eastern side of the Rockies, it has lost much of its moisture, creating a rain shadow effect that contributes to the arid conditions of the Great Plains. The year was 1900. The place, Galveston, Texas. A bustling port city on the Gulf Coast, Galveston stood oblivious to the meteorological monster brewing in the Atlantic. On September 8th, the storm, still unnamed in an era before modern hurricane tracking, slammed into Galveston with terrifying force. The Great Galveston Hurricane, as it came to be known, remains the deadliest natural disaster in U.S. history, claiming an estimated 6,000 to 8,000 lives. Decades later, in 2005, Hurricane Katrina etched its own name into the annals of American meteorological history. Katrina's arrival on August 29, 2005, brought with it not only a storm surge of unprecedented proportions, but also a cascade of failures. Failures of infrastructure, of communication, and of disaster preparedness. Katrina served as a stark reminder of the destructive power of hurricanes and the importance of robust infrastructure and effective disaster response systems. While hurricanes unleash their fury along coastlines, tornadoes, those violently rotating columns of air, carve a path of destruction across the American heartland. Tornado Alley, a region stretching from Texas to South Dakota, is particularly prone to these meteorological marvels, thanks to its unique geographical and atmospheric conditions. On March 18, 1925, one of the deadliest tornado outbreaks in U.S. history ripped through Missouri, Illinois, and Indiana. The tri-state tornado, as it became known, carved a path of destruction over 200 miles long, killing an estimated 695 people. More recently, in May 2011, the city of Joplin, Missouri, found itself in the crosshairs of another monstrous tornado. The sheer power of these tornadoes underscores the importance of early warning systems, storm shelters, and disaster preparedness education. While the South and Midwest brace for hurricanes and tornadoes, the Northeast and Great Plains face a different kind of meteorological menace: the paralyzing grip of winter storms. Blizzards, those howling combinations of snow, wind, and frigid temperatures, can bring life to a standstill, burying cities and towns under a blanket of white. In March 1888, the Great Blizzard of 1888 roared up the East Coast, dumping record amounts of snow from Washington, D.C. to Maine. New York City was particularly hard hit, with snowdrifts reaching 50 feet high in some areas. The storm crippled transportation, downed telegraph lines, and brought the city to its knees. Over a century later, in January 1996, another blizzard, dubbed the Blizzard of '96, paralyzed much of the eastern United States. This storm, which dumped up to 3 feet of snow in some areas, caused widespread power outages, closed schools and businesses, and brought transportation to a grinding halt. Blizzards, with their combination of heavy snow, high winds, and bitter cold, pose a significant threat to human life and infrastructure. Power outages, transportation disruptions, and the risk of hypothermia and frostbite are just some of the hazards associated with these winter storms. Preparing for blizzards means stocking up on essential supplies, having a plan for staying warm, and heeding the advice of local officials. While some regions battle floods and blizzards, others wither under the relentless grip of drought. Drought, a prolonged period of abnormally low rainfall, can have devastating impacts on agriculture, water resources, and ecosystems. The 1930s Dust Bowl, one of the most severe droughts in U.S. history, transformed the once fertile Great Plains into a dust-choked wasteland. A combination of factors, including prolonged drought, unsustainable farming practices, and strong winds, led to massive dust storms that darkened the skies from Texas to New York City. The Dust Bowl displaced millions of people, forced farmers off their land, and left an indelible mark on the American psyche. It serves as a stark reminder of the interconnectedness of human activity and the environment, and the importance of sustainable land management practices. More recently, California has been grappling with a series of severe droughts, with the drought of 2012 to 2016 being one of the most intense in the state's recorded history. These droughts have strained water resources, fueled wildfires, and had significant economic impacts on agriculture and other industries. Wildfires, those raging infernos that consume millions of acres of forest and grassland each year, are a natural part of many ecosystems. However, climate change, drought, and human activity are increasing the frequency, intensity, and destructiveness of these fires. In 1988, a massive wildfire swept through Yellowstone National Park, burning nearly 800,000 acres. The Yellowstone fire, sparked by a combination of lightning strikes and human carelessness, raged for months, forever altering the landscape of this iconic national treasure. More recently, California has been ravaged by a series of devastating wildfires, fueled by a combination of drought, high temperatures, and an abundance of dry vegetation. The Camp Fire in 2018, the deadliest and most destructive wildfire in California history, tore through the town of Paradise, killing 85 people and destroying nearly 19,000 structures. Wildfires pose a significant threat to human life, property, and ecosystems. The smoke and ash from these fires can travel hundreds of miles, impacting air quality and human health. Understanding the factors that contribute to wildfire risk, practicing fire safety, and creating defensible spaces around homes are crucial steps in mitigating the devastating impacts of these blazes. These historical events, these snapshots of meteorological mayhem, are more than just cautionary tales. They are stark reminders of the power of nature, of the forces that shape our world and test our resilience. By studying these past events, by analyzing the patterns and understanding the underlying causes, we can gain valuable insights into the risks we face and the steps we can take to mitigate those risks. The frequency and intensity of extreme weather events are increasing globally, and the United States, with its diverse geography and location in a meteorologically active region, is particularly vulnerable. As climate change continues to warm the planet, we can expect to see more extreme heat waves, more intense hurricanes, more prolonged droughts, and more devastating wildfires. Understanding the science behind these events, investing in research and technology, and implementing sound policies to address climate change are essential steps in mitigating the risks and building a more resilient future. But it's not just up to scientists and policymakers. Each of us has a role to play. By staying informed, preparing for potential hazards, and making sustainable choices in our daily lives, we can all contribute to a safer and more resilient future. The history of America's wild weather is a story still being written, and it's up to us to shape the next chapter. To grasp America's wild weather, we must journey beyond swirling hurricanes and towering tornadoes and delve into the intricate science behind these phenomena. The Earth's atmosphere, a dynamic envelope of gases, sustains life and dictates weather patterns. Powered by the sun's energy, it drives atmospheric circulation. Temperature differences create air mass movement, leading to high and low pressure systems. These systems shape America's extreme weather. Climate change, driven by human activities, is altering our atmosphere. Fossil fuels, deforestation, and pollution release greenhouse gases. These gases trap heat, raising Earth's temperature. This warming affects global weather patterns. More moisture leads to intense rainfall and flooding. Warmer oceans fuel stronger hurricanes. Climate change alters the jet stream, causing persistent weather patterns. Understanding climate change is crucial for future predictions. We must mitigate further warming and adapt to changes. Hurricanes are heat engines, drawing energy from warm, moist air over the ocean. This air rises, cools, and condenses into clouds, releasing heat. Favorable conditions like low wind shear and tropical waves intensify the storm. The eye wall has the most intense winds and rainfall. As it nears land, it causes storm surges and catastrophic damage. Tornadoes, those violently rotating columns of air that descend from thunderstorms, are among the most destructive weather phenomena on Earth. While their formation is complex and not fully understood, scientists have identified key ingredients that contribute to their development, particularly in regions like Tornado Alley in the central United States. The first ingredient is a source of warm, moist air, typically flowing northward from the Gulf of Mexico. This warm, humid air collides with cooler, drier air from the west or northwest, creating an unstable atmosphere where warm air rises rapidly, forming thunderstorms. The second ingredient is wind shear, which is the change in wind speed and direction with height. Wind shear creates horizontal rotation within the thunderstorm, like a rolling pin. As the rising warm air within the thunderstorm interacts with this horizontal rotation, it can tilt the rotation from horizontal to vertical, forming a rotating updraft called a mesocyclone. If conditions are just right, a tornado can form within this rotating updraft. The exact mechanisms that trigger tornado formation are still being studied, but it is thought that downdrafts within the thunderstorm, along with changes in temperature and pressure, play a role in concentrating the rotation and extending it downward to the ground. While some regions battle floods and blizzards, others wither under the relentless grip of drought, a prolonged period of abnormally low rainfall that can have devastating impacts on agriculture, water resources, and ecosystems. Drought is a natural part of Earth's climate system, but climate change is exacerbating drought conditions in many parts of the world, including the western United States. As temperatures rise due to climate change, the atmosphere can hold more moisture, leading to increased evaporation from soils and plants. This can dry out landscapes more quickly, making droughts more likely to develop and persist. Changes in precipitation patterns, such as shifts in the timing and intensity of rainfall, can also contribute to drought conditions. Drought sets the stage for wildfires by creating an abundance of dry vegetation that can easily ignite. Wildfires, while a natural part of many ecosystems, are becoming more frequent, intense, and destructive due to climate change, drought, and human activities such as deforestation and land use changes. The combination of drought and wildfires creates a vicious cycle. Wildfires clear vegetation, leaving soils more vulnerable to erosion and reducing their ability to absorb water. This can further exacerbate drought conditions and increase the risk of future wildfires. Breaking this cycle requires a multifaceted approach that addresses both climate change and forest management practices. Predicting extreme weather events is a complex and challenging task requiring sophisticated computer models, vast amounts of data, and a deep understanding of atmospheric processes. Meteorologists use a variety of tools and techniques to monitor weather conditions, track storms, and issue forecasts. But the chaotic nature of the atmosphere means that predicting the exact timing, location, and intensity of extreme events is inherently difficult. Weather balloons, launched twice a day from locations around the world, provide valuable data on temperature, humidity, wind speed, and direction at various altitudes. Satellites orbiting the Earth provide a constant stream of images and data, allowing meteorologists to track storms, monitor weather patterns, and assess atmospheric conditions. Doppler radar, which emits pulses of microwave radiation to detect precipitation and measure wind speed, is essential for tracking thunderstorms, tornadoes, and hurricanes. Sophisticated computer models, running on powerful supercomputers, use mathematical equations to simulate atmospheric processes and generate weather forecasts. Despite these advances in technology and modeling, predicting extreme weather events remains an inexact science. The chaotic nature of the atmosphere means that small changes in initial conditions can lead to vastly different outcomes, making long-range forecasting particularly challenging. However, by improving our understanding of atmospheric processes, investing in research and technology, and enhancing communication and preparedness efforts, we can continue to improve our ability to anticipate, mitigate, and respond to the challenges of America's wild weather. The breathtaking beauty of a swirling hurricane viewed from space, the raw power of a tornado tearing through the plains, the serene stillness of a snow-covered landscape. These images of nature's extremes capture our imagination. But behind the awe-inspiring spectacle lies a sobering reality: the profound and often devastating impacts of extreme weather on human lives. The true cost of these events runs far deeper, leaving an indelible mark on the social fabric of communities. From the flooded homes and shattered businesses in the wake of a hurricane to the scorched earth and displaced families left by wildfires. Vulnerable communities, often those already facing economic hardship or social marginalization, bear a disproportionate burden. Low-income neighborhoods may lack the resources to prepare for or recover from extreme events. Elderly populations may face greater health risks during heat waves or power outages. And communities of color often face systemic inequities that amplify their vulnerability to climate impacts. Understanding the social and economic consequences of extreme weather is not merely an academic exercise, it is a call to action. It compels us to invest in mitigation and adaptation strategies to strengthen our infrastructure, to build more resilient communities, and to address the underlying social inequities that exacerbate vulnerability. The price of inaction is far greater than the cost of preparedness. Along America's vast coastlines, where the land meets the sea, communities face a unique and growing threat from extreme weather events. Hurricanes, those swirling behemoths born over warm ocean waters, pose the most visible and destructive risk. As climate change warms the oceans and raises sea levels, hurricanes are becoming more intense, bringing with them higher storm surges, heavier rainfall, and more destructive winds. The images of Hurricane Katrina's devastation in New Orleans in 2005 serve as a stark reminder of the vulnerability of coastal communities. The storm surge, a wall of water pushed ashore by the hurricane's winds, overwhelmed levees, inundated neighborhoods, and left much of the city underwater. Thousands of homes and businesses were destroyed, and over 1 million people were displaced. But hurricanes are not the only threat. Sea level rise, driven by melting glaciers and the expansion of seawater as it warms, is slowly but steadily encroaching on coastal communities. This gradual inundation is already causing more frequent and severe coastal flooding, even during high tides or minor storms. Erosion is eating away at beaches, threatening homes and infrastructure. Adapting to these challenges requires a multifaceted approach. Strengthening coastal defenses such as levees, seawalls, and natural barriers like dunes and wetlands can help protect communities from storm surge and erosion. Elevating homes and infrastructure can reduce flood risk. And land use planning that discourages development in vulnerable areas can help limit future losses. Across America's heartland, vast fields of corn, soybeans, and wheat stretch to the horizon. Farmers face growing challenges from unpredictable and extreme weather. Agriculture is intricately linked to weather patterns. Temperature, rainfall, and sunlight dictate planting seasons and crop yields. Climate change is disrupting these patterns. Shifts in temperature and precipitation alter growing seasons. Extreme events can decimate crops and cause billions in losses. Droughts can parch fields and decimate yields. Flooding can inundate fields and delay planting seasons. Heat waves stress plants, reducing yields. Adapting requires innovation and resilience. Farmers adopt drought-tolerant crops and water conservation measures. Insurance and government assistance provide a safety net. Addressing climate change is essential for a stable agricultural system. Beyond the immediate devastation and human toll, extreme weather events can have cascading impacts on infrastructure, disrupting transportation, communication, energy production, and other essential services. These disruptions ripple through the economy, causing widespread economic losses and threatening national security. Roads, bridges, airports, and railways, the arteries of commerce and human mobility, are particularly vulnerable to the impacts of extreme weather. Hurricanes and floods can inundate roads, wash out bridges, and cripple transportation networks, isolating communities and delaying emergency response efforts. Heat waves can cause roads to buckle and railways to warp, and winter storms can bury roads and railways under feet of snow, bringing transportation to a standstill. Power grids, essential for modern life, are also vulnerable. Hurricanes and tornadoes can topple power lines, leaving millions without electricity for days or even weeks. Heat waves can overload power grids, leading to blackouts, and winter storms can cause power outages due to downed power lines or frozen equipment. These disruptions to infrastructure can have significant economic impacts. Businesses may be forced to close due to damage, power outages, or transportation disruptions. Supply chains can be disrupted, leading to shortages and price increases. Tourism can be impacted as destinations become inaccessible or undesirable. Investing in resilient infrastructure, such as flood-resistant roads and bridges, buried power lines, and distributed energy systems, is crucial to mitigating these risks and ensuring a more resilient economy. While the economic and infrastructural impacts of extreme weather are staggering, the human cost of these events is immeasurable. Lives lost, homes destroyed, communities displaced, livelihoods disrupted. These are the human faces of climate change, the stories that often get lost in the statistics and the headlines. The trauma of experiencing an extreme weather event can have long-lasting psychological impacts. Post-traumatic stress disorder, anxiety, depression, and survivor's guilt are common among those who have lived through hurricanes, tornadoes, wildfires, or other disasters. The loss of loved ones, homes, and communities can leave invisible scars that take years to heal. Beyond the immediate impacts, extreme weather events can exacerbate existing social inequalities. Low-income communities, often located in more vulnerable areas, may lack the resources to prepare for or recover from disasters. Elderly populations may face greater health risks during heat waves or power outages, and communities of color often face systemic barriers to accessing resources and support. Addressing the human cost of extreme weather requires more than just rebuilding homes and infrastructure. It requires investing in mental health services, providing access to affordable housing, strengthening social safety nets, and addressing the root causes of vulnerability and inequality. It requires recognizing that climate change is not just an environmental issue, it is a social justice issue. It is about protecting the most vulnerable among us and building a more equitable and resilient future for all. As we've journeyed across America's vast landscapes, from the hurricane-battered coasts to the tornado-prone plains, one theme emerges: a nation facing increasing weather extremes. Climate change is a present reality, pushing our planet into uncharted territory. Historical events like the Great Galveston Hurricane and recent California wildfires remind us of nature's power. The economic toll is immense, but the human cost is greater. Lives lost, homes destroyed, communities shattered. Yet there is hope. We have the knowledge, tools, and technology to act. The time for action is now. This is a call to protect our planet and future generations. Adapting to a warmer world requires a fundamental shift in our thinking and actions. Climate change touches every aspect of our lives, from food to homes, infrastructure to economy. We must invest in resilient infrastructure and strengthen coastal defenses. Transforming our energy system and embracing sustainable agriculture is crucial. Empowering communities and fostering innovation will build resilience. The challenge of climate change knows no borders. The emissions released in one part of the world contribute to a warming planet that affects us all. The impacts of extreme weather are felt globally, from the devastating floods in Pakistan to the prolonged droughts in East Africa. Addressing this global crisis requires a global response, one that transcends national boundaries and unites us in a common purpose. International agreements, such as the Paris Climate Agreement, provide a framework for global cooperation on climate action. These agreements commit nations to reducing greenhouse gas emissions, investing in adaptation measures, and supporting developing countries in their efforts to address climate change. But beyond government action, individual citizens, businesses, and organizations all have a role to play. We can reduce our own carbon footprints by using energy more efficiently, choosing sustainable transportation options, and adopting eco-friendly practices in our homes and workplaces. We can support businesses that are committed to sustainability and advocate for policies that promote climate action. The future of our planet and the well-being of generations to come depend on the choices we make today. Let us rise to the challenge, united in our determination to create a more sustainable, just, and resilient future for all. For in the face of adversity, humanity has always found a way forward. And in the face of this unprecedented challenge, we must summon that same spirit of innovation, resilience, and collective action to shape a better tomorrow.